All right, my friends, we know that the derivative of that function is y over 2y minus x. We're going to go ahead and figure out the value of the second derivative at a specific point. And as you are probably aware, the second derivative is simply the derivative of the derivative, and we're going to have to use implicit differentiation again. And in this case, that will require the quotient rule along with the chain rule. So that second derivative of y with respect to x is going to be low d high. So here's low d high minus high d low all over low low, or low squared. Now, unlike when we did the first derivative where we had y's and x's and dy dx's, and we can isolate dy dx and solve, we can't do that here, because we have second derivatives and first derivatives and y's and x's all together. So there's a couple options. One option is to take every single dy dx that we have and replace it with this expression, which would give us fractions times other expressions inside of fractions. And it's definitely doable. It's definitely messy. And if you want to see it at some point, I can make a video of that. But because this problem asks us to find the second derivative at a specific point, an alternative is to take this point, this x and this y value, and to plug it into the formula for dy dx, giving us a value for dy dx at this point, and then also take this x and y value and plug them in for these x's and y's here. So what I would start with is going dy dx at the point 2, negative 2 will be, the y value is negative 2. 2 times the y value minus the x value gives us a value of negative 2 over negative 6, or positive 1/3. So now I'll go through my second derivative expression, replacing every y with a negative 2, every x with a positive 2, and every dy dx with a 1/3. I'm going to pause the video while I do that, so you don't have to hear me mumbling to myself, but I would recommend you pause your video as well. When you unpause it, you're going to see all of my math and my final answer. So go ahead and pause your video now. I'll do the same. I actually am going to show some of my intermediate steps, because there's some algebra in here that you guys, or arithmetic that you guys know how to do, but you haven't done it for a long time, if ever, and I thought I'd share some steps. So the first line from here, this is just me plugging in the negative 2, the 2, and the 1/3. Not a big whoop. I give this area over here. This set of parentheses became a negative 6 times the 1/3, so I have that. These two negatives made a positive, so I did that. I had a positive 2, and I have 2/3 minus 1 all over what would become negative 6 squared. Negative 6 times 1/3, that's not too hard to deal with. That just makes negative 2. 2/3 minus 1, of course, is going to be 2/3 minus 3/3, which is negative 1/3. That 2 is still there. And then we get to this place where we have negative 2 minus 2/3 all over 36. So I know you could probably brute force your way through that. It's this next maneuver I wanted to share with you guys. By the way, feel free to put this in a calculator if you can. But it was a non-calculator question. I can see how this might be a little tricky. So what I would recommend you do is just focus on the numerator here and get a common denominator. So the common denominator here would be 3, and I would think of this as a negative 6 over 3. So I'll have negative 6 over 3 minus 2 over 3, which of course is negative 8 over 3. And all that stuff is over 36. And from here, I can think of this as negative 8 over 3 times 36. Because you can, basically, it's like you have 36 over 1. These outer guys make the new numerator. These inner guys make the new denominator. Or you could think of it that this denominator drops down to the bottom. There's a lot of ways to think about that. We could talk about it face to face if you want to. But we get to that spot right there. 3 times 36 is 108. And if you reduce that fraction, we get a negative 2 on the top and a 27 on the bottom. Pretty sure. So my final answer here would be negative 2 over 27. That's the value of the second derivative at this point for the function. I hope that makes sense. Good luck.